In this lecture, we are going to see more about MATLAB plots. So to understand this lecture better, please the prerequisite would be the lectures on vectors and the first plotting lecture that we have given. So today we will see more features on MATLAB plot, which includes y-axis. So it allows us to create a chart with two new y-axes. Then you have a text description, how to add text inside your graph. Then you have a bar graph plotting and then a pie chart plotting. So let's get started. So the begin with, we will be looking at the y-axis function. So the y-axis function, it's just a plot. It's a useful feature when you have a same x data and then but you have two different y data. So like this example. So here we're going to use the same x data. So when I say x data, it is the x-axis data. And for that data, you are having two y-axis. So you're going to have an y-axis that's going to tell about the sine wave of the data, sine, trigonometric sine of the data. Then you have another y-axis that's going to tell about the logarithmic features of that data. So here I'm generating the x data using linspace. So we have talked about linspace previously. It generates 100 linear space points between values 0 to 20. So I'm giving here value 0 to 20 and I'm generating 100 points which are linear spaced. So the linear space means the difference between the consecutive points are the same. Next, we're going to do what is the y data. So we're going to generate y data that is dependent on this x data. So the first y data, which is our y data 1, that is going to be my sine of x data. Then I have second y data, which is y data 2, which is again dependent on the same x data, but that is going to be a logarithmic values of my x data. So I have a sine values of my x data and I have a logarithmic values of my x data. So now these are my two y datas and I am going to plot these y data 1 and y data 2 on a single graph with the same x data, right? So how do I do that with this y-axis function? So y-axis function plots on the left axis, on the left y-axis, it plots the y data 1. So in my case, the y data 1 is my sine axis. And on the right side of the y-axis, it plots the y data 2, which is my logarithmic data. So I've given different colors, different line type and different markers. So we have seen what already in this plotting 1 lecture. So so that it's we can have a visually distinct representation. And here we see this. So this is my y label. So now if I give, so this is my right side, right? It represents my logarithmic data. So that is the shown in red color. And on the left side, it represents my sine data. So we can even just give a y label. What is y label? It is for sine data. And here, y-axis right, I give my y label log data. Okay. So after I give this, then you can see that I have a sine data on the left side and on the right side I have my logarithmic data. So that is my y-axis feature in MATLAB. Next, I'm going to explain how we can use text to add text to your plot. So this is very useful feature because in the plot 1 we have seen how to do x label, y label, title, so and add legends to the graphs. So these are a few things which we added that gives a descriptive information or descriptive add-ons to your plot. So here I'm going to show another descriptive add-on which is a text feature. So I'm going to create the same x data, which is a linear spaced data between 0 to 20 and 100 values between 0 to 20. And then I'm generating a y data, which is the sine values of my x data. Then I'm plotting these values. Next, I'm going to place a text inside my plot. So I want to place a text inside my plot. So what I'm going to do is I'm going to take this x position, y position. So I have to define. So text is a function in MATLAB that allows me to plot a text or write a text inside this graph. But I have to specify few inputs. The first input is my x position. So the x position is given by 3. The y position, I'm defining it as 0. So it will be plotting somewhere. So let's just see where it's going to plot. Yeah. So this is my 3, 0. So it starts at 3, 0. and it gives, what it writes is it gives a left arrow, so that's what we see here, followed by a sine wave. Next, I'm giving just numeric for my x position. So at 9, 0.5. So if I see this 9, 0.5 will be somewhere here, and exactly at that point, it's putting a right arrow and defining sine of theta. So we can type special characters, latex descriptors. Latex descriptors, I'm uploading that list of commands on the GitHub. It's in an editable format, so you can easily use it for your application. Okay. So this is pretty much how we throw text into the graph. You can have any graph, you can write text, you can use text to write things inside your graph, including values, numeric values, alphabetic values, alphanumeric, then mathematical descriptions like theta, alpha, beta, using the LaTeX representation. So this is a pretty useful feature when it comes to graph labeling. Next, we are going to see how to do a bar graph and a pie chart in Matlab. So this is another thing that we may have to do from time to time. So apart from using the generic plot, which is the plot statement, we have features like bar graph, pie graph, stem, stairs, plot YY. So we're going to see some of those in the next lecture. Today we'll see two of those additional graph features or the plot features of Matlab, which is bar and pie. So the bar chart here is what we'll be saying. The same way I'm going to generate just 10 points. So I'm generating only 10 linear space point as my x data between values 0 to 20 because it's a bar chart. The bar chart is only useful when you have a relatively small number of points or samples. If you have like 1,000 samples and if you plot it on the bar, it gets too crowded. We'll show that also. We'll see that example when you have a lot of data and you use a bar graph to plot that data. So the bar graph is very useful when you have a small number of samples and it is more on the descriptive side. Suppose you have a statistical data like year versus salary, or year versus number of admissions, or year versus number of votes. So these kind of statistical, these kind of relative things you can plot on the bar graph, but not like mathematical plots like a sine wave, logarithmic wave, exponential wave, or a cosine wave. So these kind of things you need the plot command. So I've taken random data, then I'm generating the y data, which is the square of an x data. So to do the square, I'm using an element wise power. So what is an element wise power? So it's a dot given by a power. So this also we have seen. So this is an useful feature here because it takes each element of x and it squares it. Okay, so it takes each element of square, because otherwise x data square, what it does is normally if I give x data square, it's going to do x data star x data. So this is like, this becomes like a matrix multiplication. But if I give x data square, so it's going to do element wise squaring, which means each value inside x data is squared. Good. So that's pretty much what element wise it's here it's element wise powering. Right. So this is what it means. Yeah, so that will take care of the squaring. So it's gonna square the x data values, and that's my y data. And then I'm gonna plot the graph. So I'll just disable this for a minute, and then I'll just show you guys a few things. Well, let me just keep this also, and just let me plot this. Yeah. So now what do you see? So you have seen that the bar graph is overwriting on our previous graph. So the previous output that we had, that was the figure handle, and it's just overwriting on that. So that is why we want to be a fresh graph. So I am just plotting it in this manner. So I get a separate graph. Nice. So this is my bar graph, x versus y, x data versus y data. And now this is my bar width. So I can change this. Let me just make it very thin bar graph. So this is the slim bar graph. So the original one is this, and the bar width equal to 0.2, I get a data like this. This is a useful feature. So what happens is, okay, I'd like to show that also. So let's increase the number of points. So we move from 10 points, we are going to have 100 points. And then let's just plot and see what happens. See this? So you cannot pretty much distinguish, because here we have a square, we have a kind of a square wave, it's just the square of the values. So it's not a square wave, it's a square of the values, and that is giving you this kind of shape. So each value is going to increment and you get a quadratic. It's like y equal to x square. So this graph is pretty much y equal to x square. So this is, we can even, maybe we can put a text there. I'll take this text and I can put, maybe in this graph we'll put a text, and we'll say that this is a right arrow, y equal to x square. So what is this graph? Y equal to x square. So this is my graph. Okay, and then the position should be like somewhere like 10, 350. So let me give x-axis to be 10 and y-axis to be 10, 350. Yeah. So yeah, so the graph is like a y equal to x square, and here when I slim it a bit, I still see. But what if I have 1,000 points? So 1,000 samples in a sine wave is like nothing. It's just too small. So it gets very crowded. You cannot distinguish between these individual bars, right? Individual graphs. So typically we don't use bar graph for samples which are greater than, like in greater numbers like 1,000, 10,000. But for a smaller dimensions, this is very easy to plot and very informative. It can tell a lot of information about the input versus output data. So that is one of the bar graph. Then let's come to the other features in bar graph is you can plot two y data in your bar graph. So just like how we had y axis previously, here also I'm generating two y data. So y data 1, which is a square, x square, y equal to x square. Y data 2, which is x cube, y data equal to x cube. So this is y equal to x square, and then here I'm having y equal to x cube, and then here I just y equal to x by 2. So I'm three different variants of x data is my y data 1, y data 2, and y data 3. And then I'm going to do what I'm going to do is I'm going to concatenate this y data. So I'm going to put one after the other. So this is vertical concatenation. So we have two types, vertical and horizontal. I've mentioned this in detail on my vectors lecture. So I'm just going to do this concatenation. So I'm just going to make it into a single data. So what happens when I do this concatenation? I'm going to get my y data, right? So I'm going to get a y data which is going to be these three data built together. So let's just run this program. So now this is my y data, and it is 3 cross 10. If you see this y data, it's 3 cross 10. The first row is my y data 1, the second row is my y data 2, and the third row is my y data 3. So I put these three data together, and then now I'm calling my bar graph x data, y data, bar width, and my bar width is 0.2. Let me just scale it up a bit. So I get a 0.5. Then I come to this bar. You can see that I have plotted 3. So the first one is my y data 1, the second one, the orange, is my y data 2, and the yellow is my y data 3. So it plots all three of it. That's very useful. Then I have another feature in Matlab that's very useful for bar graph. So that is your stacked display. So I can also stack this. So what happens is I'm plotting the x data. So x data is somewhere around 5. So the y data is somewhere around less than 10. So I'm just plotting one on top of the other. Okay. So just after the x data gets, after the y data 1 gets over, you put the y data 2. Then after the y data 2 gets over, you put the y data 3. So that's just stack one after the other. Y data 1, y data 2, y data 3. Just how it is stacked here. So here it is a 3 cross 10. So it's your y data 1 first, then y data 2, then y data 3. Here this is what you're going to see. 4.4 is the height of your first y data. Then the next one is 6.67, and the third one is 1.11. So this is how your height will be. And then for the next bar, it will be 8.89, then 13.33, and 2.22. So these will be the heights for the stacked display. So this is how you do the stack display, and it just at times it's useful to see how your data. So here you can see that your y data 2 is considerably having a big, and compared to that this is too small. You can tell that from the combined bar graph. Okay. Yeah, so this is how you plot bar graph, and then we have the pie chart. So this is pretty again another useful feature. So I'm going to generate 3 linear space points between 0 to 20, and then I'm just going to use my pie data. Okay, so this I'm not going to, it's relatively simple. So you want a pie chart, you can plot it. So this is giving the percentage 0, 67 and 33, but you want the exact percentage, you can plot, you can call the float. So this is the floating values, right? So it just says 2 decimal places. So what does this float says? 2 decimal places. So I get this 0.00, 33.33 and 66.77. Next, I have the floating values with the percentage, because here what is the difference between the first pie chart and the second pie chart? You don't see the percentage. So in the first pie chart you see 0%, 33% and 67%, but in your second pie chart you see only 0.00, 66.67 and 33.33. So you don't see the percentage in the second pie chart, which is taken care with this third program. So I just put a pie chart after my point to f. So it says that you end the floating value with the percentage. Okay, so let me put, yeah, so I have to put 2%. So it just says that first percentage is for ending this float value, and the second percentage to end this percentage that you see here. So that is pretty much about bar chart and pie chart. So those who have that feature pretty much can use it. I myself prefer mostly stem and histogram, but we'll see that in another lecture. Okay, next we are going to see how to plot graph side by side using subplot or tile layout function. Let's we have an input data which is a linear space data between 0 to 20, and 3 values we are going to generate. Y data is the square of x data. So now the subplot can be used. So what I'm going to do is I'm going to plot a bar graph, a pie graph, and 2 plot graphs on the same figure window. So I'm going to plot them side by side so that I can use them for comparison, I can use them for presentation, I can use them for better analysis if I have them on the same window. So for that I have a function called as subplot. The subplot is going to have the syntax 2, 2, 1, which represents create a plot array. So create an array of plots of size 2, 2. So you can have up to 4 plots arranged 2 rows and 2 columns. So 2 cross 2 means it has 2 rows, 2 columns, and the position is 1. So this 1 gives the index, the position of the graph. So 1, 2, 3, 4. So you see this. So I can put this as position 1. Then I can put here for the second graph, this is my position 2, and then position 3 and position 4. So I can do this so that, and I can also change this position numbers. It doesn't have to be in this order. So let me keep this as position 1, and then let me keep this as position 4. So I can just do this in either way. So when I plot this, so I'm going to first see the graph. So I have plotted the first position. I plotted a graph which is going to have a red line with 0 or O markers. So I've got this O markers, and then the second index is my position 2. So position 1 is this, position 2 is my pie chart. I'm seeing this in the position 2. Position 3 is again my plot. It's just a default plot in the blue color and a dotted marker. Then you have the bar chart. So I have done this. I have plotted all 4 graphs in the same window side by side using my subplot function. So subplot function is a useful function. Now I'm going to introduce another option which is tiled layout, and this is a very good option because it's much neater and much simpler than the subplot. So I'm just going to display it in a new figure. I'm generating a new figure, and I want to define the size of the tile layout. So size is 2 cross 2. It is again same row column. So 2 cross 2 is 2 rows and 2 columns, and then I'm just going to plot just give next style. So my first style is going to be this, the second style is going to be the bar graph, the third and fourth style is going to be this. So this pie chart followed by a bar graph followed by the plot with the default option and the plot with the red line and the O markers. So now I can just increase the size of the style layout. I just make it 3x2. What happens? So you will see that it has created a 3x2 array, but it has plotted only in the first 4. So it has left the last 2 blank because I have not given any graphs for it to plot. So what if I give it a 3x3? It will create a 3x3 array and it will plot the first 4. So this is my first 1, 2, 3, 4. So index 1, index 2, index 3, index 4, 5, 6, 7, 8, 9 is left blank. So I can just, if I give 2x2 the same way, it will plot the first 4 graph. So this is a much neater option. I would say, like, rather than going for subplot, I normally prefer this option. So you can use either of it to plot these graphs in the same window for comparison, for presentation, for analysis. This will be very, very handy. Okay, so that is, I think that should do for today's lecture. I'll upload the codes in the Git link in the description, along with the LaTeX descripting texts that can be used for Matlab. So feel free to go through the code, use it. Any doubt, post it in the comments. See you in the next lecture. Thank you.